I was in my first year of graduate school to study evolution when my advisor said, "We are going on a field trip. We are going to spend spring break visiting 1 billion years of reefs." A billion years? How long is a billion years? 1,000 million years. How long is that? About 50,000 human generations. Year one of graduate school, you try not to look surprised, so I nodded along. I didn't know that reefs lived in the oceans a billion years ago. I was just starting my studies, and I wasn't used to thinking about deep time yet. For 10 days over spring break, we drove around California and looked at fossils and ancient reefs that are now exposed and easily accessible on land. We started at the Crystal Springs Formation near Death Valley. We scrambled up the outcrops and looked at layers of complex reef structure called stromatolites, built by bacteria a little over a billion years ago. And later in the week, we camped on fossil coral reefs from the Triassic. They were hundreds of millions of years old. Many different kinds of organisms build reefs, from microbes to mollusks. But when most people think of reefs, they think of coral reefs. Corals are colonial animals that have been building calcium carbonate structures for over 400 million years. They have appeared and disappeared multiple times since then. We can see these disappearances as gaps in the fossil record. Modern corals, related to the animals that build coral reefs today, are called scleractinians, and they first appear in the record 240 million years ago. The coral reefs we know today are magnificent. They are repositories for unbelievable biodiversity. 25% of known marine species live on coral reefs. They build enormous structures that protect coastlines and provide food for over 500 million people around the world. And they are beautiful. The colors and textures are inspirational. Modern corals are a photosymbiosis. There are many microbes associated with coral animals, but my work focused on populations of the single-celled algae that you can only see through a microscope. They live inside corals and many other reef dwellers, where they have everything they need to turn sunlight into energy via photosynthesis. The energy feeds the corals and forms the basis of the food web. This algal-coral symbiosis powers the entire ecosystem. But under stress, the symbiosis breaks down. The algae disassociate from the coral host, and the host starves without the algae. If the symbiosis is not reestablished within days or maybe weeks, the coral dies. And when corals die, the reef starts to degrade. The structure degrades and the other organisms lose their homes and their food source. There are many kinds of stress that can cause symbiosis breakdown. Warm water is particularly stressful. I ran a series of stress experiments. We collected corals off the reef and put them in tanks with water heaters to expose the coral fragments to temperature stress. We turned up the heat just 4 degrees Celsius to simulate the increasingly common extreme heat events that we measure in shallow coastal zones. The symbiosis broke down in just a few days. This is called coral bleaching. When we turned the temperature down, the symbiosis slowly reestablished and the corals started to recover. And since those trials, a lot of other scientists have run similar experiments. They are starting to understand how and why warmer water causes the symbiosis to collapse, although there are still many unsolved mysteries. Our oceans are warming rapidly. Food webs and productivity are altered. Fisheries are shifting, and many regions of the ocean are now regularly exceeding the range of temperature that corals can tolerate. As the oceans stay warmer for longer each summer, symbiosis is breaking down across large swaths of reef. Large-scale bleaching events make the news. And as I tried to navigate the storytelling around our bleaching experiments and their implications for the future of coral reefs, I kept hearing the word fragile. Scientists around me use the word fragile. The headlines in the news and online all screamed about how coral reefs are so fragile. Coral reefs are the canary in the coal mine, the Achilles heel. They will be gone in 50 years or 30 years. Apocalypse fatigue is real. And then family and friends would call me because they too had seen a video or an article or something online about how coral reefs are so fragile. I was confused and a bit frustrated. Yes, many of us have shown that symbiosis is sensitive to changes in temperature, but fragile means easily destroyed, and I think reefs are robust. I had seen the long history of reefs. I had seen recovery in the fossil record. I had seen recovery from hurricanes and other physical damage. I had even seen them recover in my tanks. So maybe my family and friends were just worried about my job security as a coral reef scientist? But the symbiosis is clearly sensitive. The corals would die if I didn't intervene and turn down the temperature in those tanks. So on top of demoralized and scared about the future of coral reefs, I was frustrated and overwhelmed because I had to describe corals in science talks and in casual conversation. And how do you explain that they are both robust and sensitive? I spent a lot of time in this quandary trying to figure out how to talk about my science. This was really stressful. And eventually I realized, of course, that both perspectives are important. Two observations that seem contradictory tell different sides of the same story. We are desperate to categorize and clearly delineate right from wrong, but sometimes systems are complex. Coral reefs are complex. Climate change is complex. So sometimes multiple perspectives can be helpful. I'm grateful for this lesson that I learned, and since day-to-day life in 2020 is riddled with frustrating contradictions, I'm really glad that I learned this lesson from coral reefs, of all things. A political theorist named Danielle Allen works on issues of justice and equality. And I think she says it really well. When confronting the history of this country, she says, let's learn how to tell stories from multiple perspectives at the same time. I think that this experiment, as she calls it, can be applied to many things. But I get worried because sometimes when we hear two different conflicting messages, we get paralyzed, we get overwhelmed, and we freeze. Who is right? What is true? What is the right thing to do right now? When we have a problem as big and complex as climate change, I just don't see how we can avoid this scary multiple story scenario. But when we hear the different stories, we cannot afford to be paralyzed. We can remain skeptical, and we should read up on trustworthy research. But please do not let the mixed messages stop you. The point is to get involved. Different perspectives can lead to positive action. I see it all the time in my community. There are people fighting for policy changes that will reduce carbon in the atmosphere and slow down warming. There are also people building coral nurseries and gardening coral so that they can replant and restore reefs. The policy people argue that without reducing climate change, there will be no viable ocean habitats where corals can live. But the restoration people argue that if we don't save the corals themselves, it just won't matter. This is an argument about how to allocate limited resources. But both camps are right, and we need both of them working on the problem from multiple angles at the same time. We need diverse voices speaking and acting from different perspectives. Some of you are already working frantically because you know that we need to get this climate thing under control. And I am so happy about that because anything we can do to reduce or reverse ocean warming will benefit coral reefs. And for the rest of you, I challenge you to hear the contrasting stories and use them to explore and ask questions and seek out reliable information to generate wonder and to find your own point of entry. What confuses, frustrates, or intrigues you? Use that. I'm intrigued by symbiosis. How do these unlike organisms live together? I have been face to face with the fossils and the living systems. I see them experiencing stress, responding to change, tolerating, and recovering, and dying. So how do I reconcile these contrasting perspectives? The long term gives me comfort. I know that reefs are robust and that they will survive deep into the future. Maybe they will be interesting in unimaginable ways. The short-term perspective is passion, and passion inspires action. I think that the coral reefs of today are special because the reefs that I know the best are the ones that I love the most. And modern coral reefs are not doing well, but they are magnificent and they are worth fighting for. Our oceans are warming faster and things are going extinct at alarming rates. We cannot freeze. We each have to find our own way to do something, to get involved, to take action, because there is no way that 1 billion years of reefs is over yet.